it's go time. Hi, everybody. Mr. Samuelis here with the first live lesson. Student, are you there?
Yep.
You're on YouTube. All right, here we go. You can read all this. In fact, you might want to pre-read some of this stuff because I want these lessons to be pretty quick. When we get to into the book later, yeah, I don't know if we're gonna, hopefully we'll share the notes ahead of time so you could look at them blank and then go from there. But anyway, I'm blabbering. Let's get right to the solid notes here. Trying to hit that and it wasn't going. These are pluses and minuses. Now, again, you're probably rolling your eyes. I know how to do this. But what we have here is questions that I teach my Math 2 class as well. I have that this year. This is our lesson Monday. We're actually, the things that we're doing today, and I think just today, and the lesson that's later that you have to do on your own, we're doing in Math 2 on Monday. But you're getting, like, this is review, and you're getting the tough questions right away. So here's the silliness of what some people do, and I like teaching with, most common mistakes. They ignore the plus signs and they start going ahead and multiplying. Ay, caramba. First of all, you just jacked up that question and it's completely wrong, and you made it infinitely hard. This is just adding like terms. One of the biggest mistakes all year long that I will see from you if you're like my students of the past for 25 years is not distributing a minus sign. So please do not do that. Please do distribute the minus sign. Anyway, adding like terms. I like to just do this. Get the highest term. By the way, I should stop 6n to the fourth and answer these questions down here. The leading coefficient is the coefficient in front of the highest degree. So it shall be 6. And the degree, as we just said, is 4. That wasn't COVID cough. I just, sometimes I cough just as a response. Student, are you okay? I heard something.
Oh, I'm fine. Yeah.
Okay, good. All right. Then the next thing, go to the next highest degree. Well, actually, those completely cancel. Oh, and by the way, I get rid of this because I have it down here and I don't want to see it anymore. So just giving you some hints about how you can, oh, come on. I lost my pen. All right, I'm pressing pause. Sometimes this happens. I'm going to make sure I'm taping anyway. Okay, these tech issues happen all the time. Okay, these cancel because they're opposites. Oh, but wait, I have one more n to the third, and it's negative. So minus n to the third. Blah, 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 right? This is too easy. N squared. So just keep track. Those that actually struggle in CAT, I think they're a little messy, and they don't have ways of organizing their stuff, and then they lose a term here and there, and they write a wrong answer because of carelessness. All right, so just be careful on that, and I'm done with that. Let's move on. In this scenario, I'm going to have to change, how we do this probably throughout the year, but for today, I'm just doing the lesson. If you have any questions, meet me at 2 to 3, okay? Last hour, I was short on finishing, so I told them to watch the end of this video that I'm making. Anyway, blabbering. This is a distribution. I'm going to do it super fast. And again, see me at 2 o'clock if this is too challenging. What do you do with these exponents? You add them. Like I said, this is a college class. You need to focus. If you're falling asleep and blah, 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 and making mistakes later, you're your own worst enemy. All right, sorry for the negative statements as I do this math. All right, so that's just a distribution. By the way, I do want to do this. Get ready to flip your page here. This whole side is multiplying. So you have distribution. I put the 4-letter F word FOIL. I wish we were in class because I would say, how many teachers used the word FOIL last year and years past? And many teachers treat it like a 4-letter F word. They think it's terrible, and I don't. I talked to Mr. Zaworski in the who's had Mr. Zaworski? Raise your hand. I can't see you, so that didn't work. He knows what the word FOIL is, and he's a history teacher, and he's old and decrepit like me, but it works. He remembers the acronym. Anyway, multiplying is the reverse of factoring. So I want you to understand that what we're doing on this page, the next page, we're going to reverse it. The answer in this question will be the question on the next page. So when I distribute, I get this answer. When I factor, I get this answer, which is just the reverse of distribution. This would be, it has a greatest common factor is what that's called. I don't think students understand that enough because over the years, factoring is a disaster, and I don't get it. It's a very simple process. If you understand foiling, then you should understand factoring. Those are the first two terms if you've never heard of the word foil. I'm saying it. I don't care. Those teachers that say this is an illegal word, they're silly. Those are the outer two terms. Really, what those teachers said is go ahead and distribute that 3n to the fourth. Fine. And then distribute that -7. Fine. I just like the word foil because it does lead into what I like to say about factoring. What? I don't know. That was a brain mishap. There was a little short circuit in my brain there. 3 times 6 is 18. Did I write an 8 there, students? Is that what I wrote?
Yep.
Okay. I forgot 18 n to the fourth. And then -7n squared. And then 18. I'm sorry. And then that's inner, sorry. And then that is last. That's where the word FOIL comes in. Those are the last two terms in each binomial. That's -42. FOIL. Next page, you're going to get this question, and you're going to factor it. And then that will be the answer. So that's what I want you to understand, the difference between the two as I teach this lesson together, multiplying and factoring. By the way, with a 4-term polynomial, that would be factoring by anyone. Student, you go ahead and tell me if you know the answer. G R O. Anyone open up their mic and answer? So if I were to factor this 4-term polynomial to get this answer, this would be the method that I would factor this to get this to be the answer. U. Anyone? Nobody? P. This is great YouTube. I might have to cut this part out. I can cut videos. The word's almost done. I. N. There's only one more letter. Grouping. Okay. I'll cut that out of the video. Anyway. Excuse me. Not COVID. I just accidentally had a. Okay. Now, this is not equal to 2n cubed minus y cubed. Incorrect. You had your notes that you should have watched the Ed puzzle, and I think we did have some of these questions. This is true when it's 2 times n times y, 2 cubed n cubed y cubed. This is incorrect. What this is, and I'm not going to be able to do this all the way. If you need to see this later, go ahead. Again, this should be review of how we get these terms, and just be careful on keeping track of your stuff. You would FOIL this, get that answer, and then multiply it by this. And that would be more than a FOIL. There'd be 6 multiplications and so on and so forth. But because of time, I want to get to the factoring. Same thing with this one. You do not distribute. No. You do not square and square. What you do is write this 3n plus 5 twice, because that's what a square means. And then I'm going to do the same like the last example. FOIL. Get that answer. And then distribute. That's a PEMDAS thing. You do exponents before you multiply. So you have to multiply after the fact, right? This becomes 9n squared, 15n, and 15n is 30n, and then that's 25, and then you distribute to 2n to the fourth, which I showed you distribution. And I'm going to skip this one. I think I skip it in the homework. If you wanted to come to me and see that, it would only take me a couple minutes to show you how to do that. Probably not even. All right, now the grand factoring page. You're going to have to factor fast. I know your teachers probably showed you one method, but actually that's been different. Some teachers teach different things. When you get to CAT, you must recognize what you have and factor the fastest way possible, okay? So, and that's all I'm going to say about that. And dots, we're going to talk about that, and that these are 2 special cases. Always look for a GCF first. So this is listed first, and it is first. Then after that, you recognize what you have and determine what method you should use. So this is going to be a process. I will tell you, we are going to factor frequently in this class because it actually just throughout the whole year, it comes up. Factoring is a huge skill that needs to be done. The first thing that you look for is a greatest common factor. This is the reverse of distribution. You're pulling out an n out in front, and then good FOILers are good factors. You're going to hear that from me forever. Good distributors are good factors. Did you hear that whistle? So I know if I threw this back in, I'd get this, and I'd get this. So that means I factored it correctly. This is what I mean when I say this a billion times. Good FOILers are good factors. Good distributors are good factors. And then the next thing is, this is a trinomial that is in what's called quadratic form, n squared n constant, with 1 as a leading coefficient. I'm not doing no tables. I just do MA. M, what multiplies the 2, and at the same time adds to -3. Student, do you know what those two numbers are? What multiplies to be +2, then those same two numbers are added to be -3.
Yes.
Do you know what they are? What are they?
Oh, -1, -1, or -2.
Good FOILers are good factors. You are correct. Maybe I should, man. I wonder if I could do this in lessons where I could pick random students. All right. What just happened there, Mr. S? Okay, when you have a trinomial that's in that quadratic form and MA has magic numbers that work, good FOILers are good factors. N times n's n squared, that's first. -1 times -2, last. That's positive. So far, so good. And then for outer and inner, ooh, what happened with that little line there? -1n plus -2n is -3n. This is what I mean about good FOILers being good factors. After you factor, you check your answer. If I were to multiply this, does it end up being that? Yes. So therefore, I factored it correctly. That's why I approach this lesson the way I do. All right? And hopefully you understand that. Got to move on. 7 minutes. Like I say, after school, 2 to 3 if anything's too fast. Difference of two squares. Oh, yeah. That's what this is, dots. If your teacher didn't teach you that last year, 2 years ago, fine. I'm teaching you now. You got to figure it out. Right away, when you see a minus sign, and this is a perfect square and that's a perfect square, you therefore have a difference of two perfect squares. They automatically factor like this. It is a binomial times a binomial. 8 times 8. Hey, first, 8 times 8 is 64. Factor, FOIL. And then what's the perfect square of 25y squared? 5y, 5y. Last, 5y times 5y is 25y squared. Wait, something's missing. I have a -25y squared. So one has to be plus and one has to be minus. That is the pattern for factoring a difference of two squares. Wait, Mr. Samuels, you didn't do O and I. O, -40y, I. I'm sorry, what? That's the wrong line. Strike that, strike that, strike that. O, I. My bad, dogs. 5y times 8 is 40y. So -40y and +40y cancel out. That is why there is no middle term in this. All right? So again, I'm taking a long time to explain this, but for you, this factoring should be 5 seconds. Then you spend another 5 seconds. Am I right? And then you reverse real quick and think, when I multiply this, do I get the answer? That is the purpose of good FOILers or good factors. Okay, real fast. Always look for a GCF first. Running out of time, I want to get to the tough ones. Next thing is, here we go, difference. N to the fourth is a perfect square, and so is 25. Don't forget the 5 that you pulled out. Perfect square of 25 is 5. Perfect square of n squared is n. Minus plus, ooh, I switched it. Does it matter? The answer is no, it doesn't matter. It's all okay. I could put plus minus or minus plus. Good FOILers, good factors. N to the fourth. -25. Middle term cancels with O and I. Let's move on. This is a sum of two perfect cubes. Perfect cube of y to the third is y. Perfect cube of 8 is 2. You have to be numerate in this class. You have to understand numbers and be good with them. And this is the classic sum or difference of two cubes. SOAP I showered today. Did you guys? Never mind. I wouldn't have if I stayed home. I had my hat on a lot of the mornings when we were doing e-learning last year, so it's all good. My White Sox hat. Hey, Sox Cubs this weekend. Anyway, SOAP. Here's what SOAP stands for. This is a formula. This is something you're going to have memorized and lock it in. SOAP. This stands for same. And I wish I was in class. How many people remember SOAP? And I bet you over half of you would raise your hand. Same is same sign. O is opposite of whatever that sign is. And then this is always positive. So when you factor this, you get a binomial times a trinomial. And it's very simple, and it's very simple to check. At least have a reasonable right answer, and then maybe your signs might be off a little bit. You get a lot of points for that. So the first term is the perfect cube of this. The second term is the perfect cube of that. So y plus 2. And I'll show you why this works right away. Then this term is this one squared, or this one squared. Now look right away. When I take this times this, remember what I said? Factor, FOIL, or multiply, and I should get that back. That's the relationship between factoring and multiplying. When I take y times y squared, I get that y to the third. Good. A lot of times when people put the wrong answer for sum of cubes, that doesn't even match. And then really it's the next part that doesn't, that I'm going to show you. Middle term, just take these two or these two and multiply them. That's 2y. Last term is just this or this squared. For last, plus 2 times plus 4 is positive 8. So good. Just by checking this and this, I see that I have those components. This is the biggest missed number right here. I don't understand students that miss that when I tell them, hey, check real quick. Just make sure those match. And then move on. Or if you have the time, check what happens with this, 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 and this. And those that are really good, if you check those green lines, they end up being opposites of each other and cancel. So those green lines completely nullify when I multiply this to check, does it end up being that? So long story short, this is the pattern for a sum of two cubes. Guess what the pattern is if it was a difference of two cubes? If I change this to a minus sign, the only thing that changes is same. Ah, shucks. Opposite. All right. So I'm going to pause the video for a second. And I'm exactly, like I said, wanted to finish this off. Here's another classic MA. What did I skip here? Well, this is a difference of two cubes, but I did show if I turn this into a minus sign, SOAP, same, opposite, always positive. And then look how it actually works. Still get that y cubed. But now you get negative 8 when you multiply these two. There's minus 8. So I just changed, what if it was a difference of two cubes? Okay, so that's the only difference. Sum of cubes and difference of cubes, very similar. One minor little difference, what happens with the signs. Okay, classic MA. This is how fast factoring should be. 2 times 7, 2 plus 7. Oh, wait, I'm not sure. N times n squared. 7n and 2n is 9n. 2 times 7 is 14. I don't understand why students make such a big deal about factoring. Every single year I lament that case, and every single year it comes up to be true that students just really have a hard time figuring it out. All right. Oh no, this is a bad one. Okay, it is a y squared and a y, so and a constant. So this is going to be two binomials. I'm going to put the final answer down here. Then I'm going to show you what you might have learned as a trick when it's not one in front. Okay, but what I'm going to do is some trial and error, and this is going to be kind of tough because there's a lot of options for 14y squared. It could be 1 times 14, each having a y, and 2 times 7. There's really not a lot of options. I've already, because I'm good at factoring and numerate, and many of you are, I already know that it's going to be 7y and 2y. This really makes me sad how many people don't understand factoring enough. They don't understand that their answer, at least when I write these two terms in the binomials, this times this has to equal that. Because Because no matter what your teacher taught you last year or the year before is tricks for factoring, you get caught up in the trick and you don't even understand what you're writing as a final answer, that it has to multiply to be, um, that scenario. So I know it's going to be that and not 1 in 14 because I already got this figured out. I'm looking at the middle term and I'm a good foiler. So I know -5, this times this has to equal -5. That's good foiling. And I know I need a -5 here because I'm thinking ahead. This has to be a big term. That's -35. And a -5 times 1, 1 times 2 is 2y. -35y plus 2y is -3y. I know it's the right answer. That's what factoring is. It's unfoiling. What is the multiplied form that equals, what I have originally? So foil, no, wrong. Factor, foil. And that's the relationship, and that's why good foilers are good factors. But there is a way that many teachers teach, but then I find over the years some teachers stop doing it. There was a trick. This is a trick. Take these two and multiply them. Trick, trick, trick. -50, -20, -70. Okay. So now this is our new MA. That's our new M number. When this is not 1, if that was 1y squared, M would be -5. It's not. This changes everything. What multiplies to -70, but this is still the A number, which is -33. Now, what two numbers multiply to this but add to be this? It's -35 and 2. Now here's what's sad. Some people write that as the final answer. Got it. So I factored. I found the magic numbers. What are you doing? You are totally caught in a method and have no clue what the relationship is. Y times y is not 14y squared. -35 times 2 is -70. How could we possibly write that answer? Anyway, excuse me. Okay, sorry, I got lost there. What do you do next? You take that middle term and you split it up into these. So you write an equivalent expression to this, splitting up the middle term into those magic numbers that make this MA possible. And then I'm working ahead of myself. I said the word grouping before. You group these two. And then when you group, and you got to leave this plus sign in here, you group and take out a common factor between these two terms and put it outside here. Well, both 7 and y go into this, and you're left with 2y. Again, good distributors, good undistributors, minus what times it's 5. And then that's it. Plus, now you know what you want to pull out of this one? You want to see that 1 pulled out. There is no common factor between these two, but you want to do that. Now, actually, the answer is ready to go. You treat this as a binomial GCF and pull that out, even though I have it. So you undistribute this, and then you're left with a 7y plus 1 by themselves. And then that's how that actually factoring works. So if you need a trick, if it's hard to unfoil this because 14y squared and -5y are hard to figure out, this method always works, and it's supposed to be taught that way at Lockport, but we'll see if it actually is. And last but not least, because I got to get into my next class, actually I'm going to press pause and probably open that. Okay, last but not least, 4 terms. I actually talked about this during the 6-hour lesson, and student popped in, I believe, but this is a classic 4-term polynomial. You already have the note sheet, so I don't have to erase that. So really give this a try. Try grouping and then pull out a common factor between these terms that I've grouped together. So always when you have a 4-term polynomial, the only possible way you could factor it is by grouping. Just like the last one, pull out a 1 just so you see it. They don't have anything in common. So you want to pull out that 1 and then look at this. This is a greatest common factor between these two terms, I guess we want to call it. That's a term and that's a term if you really want to look at it that way. So what we're going to do is yank that binomial as a greatest common factor. And then what I'm left with is n to the fourth plus 1. And I'll write that right there. Be careful in all of these. That is everything factored completely. I wish we had better examples of this. The only one that we had to do a couple things with was this one and this one, where you had a GCF first, then you had to keep going and see if you had additional things that you could do. Okay, I'm done. I got to move on to my 7th hour.